Hello everyone, and welcome back to David IB course. It's great to have you here again. Today we're going to tackle a super useful topic: how to solve exponential function problems using logarithms. This is a classic question you might see in your exams, and once you get the hang of it, it's actually pretty straightforward. So grab your notebooks and let's get started. Let's imagine a scenario. The initial population of rabbits on a farm was 50. The population then increased by a steady 7% each week. The big question is, how long would it take for the population to reach 500 rabbits? This is a perfect example of an exponential growth problem, and we're going to break it down step by step. First things first, we need to set up our equation. We start with our initial population, which is 50. This population is growing by 7% each week. To represent this growth, we multiply by 1.07. Why 1.07? Well, the 1 represents the original population, and the 7 represents the 7% increase. Since this happens every week, we raise 1.07 to the power of n, where n is the number of weeks we're trying to find. We want this all to equal our target population of 500. So, our equation is 50 times 1.07 to the power of n equals 500. Now, let's solve for n. To make things simpler, we should try to isolate the part with the exponent. We can do this by dividing both sides of the equation by 50. On the left side, 50 divided by 50 cancels out, leaving us with 1.07 to the power of n. On the right side, 500 divided by 50 equals 10. So, our simplified equation is now 1.07 to the power of n equals 10. This is where logarithms come into play. When the variable you're solving for is in the exponent, taking the logarithm of both sides is the key. So we'll apply the log to both sides of our equation. This gives us log of 1.07 to the power of n equals log of 10. Now if you're using the common logarithm, or log base 10, you'll know that log of 10 is simply 1. That makes things even easier. Next, we use one of the fundamental laws of logarithms. This law states that the logarithm of a number raised to a power is equal to the power multiplied by the logarithm of the number. In our case, this means we can bring the n from the exponent down to the front. So log of 1.07 to the power of n becomes n multiplied by log of 1.07. Our equation now looks like this. N times log of 1.07 equals 1. We're on the home stretch. To get n by itself, we just need to divide both sides by a log of 1.07. This gives us n equals 1 divided by log of 1.07. Now, you just need to pop that into your calculator. When you do, you'll find that n is approximately 34.03. So what does this mean in the context of our problem? It means it would take approximately 34 weeks for the rabbit population to grow from 50 to 500. See? By breaking it down, it's not so bad. I hope this example helped clarify how to use logarithms to solve these types of problems. Thanks so much for watching. If you found this video helpful, please give it a thumbs up and don't forget to subscribe to David IB course for more math tutorials. See you in the next one.